just gonna give it a second, make sure that we are live and everything is looking okay. Let me just check here. All right. Looks like we are good. So, without further ado, good evening, ladies and gentlemen, and welcome to the Skywalk Podcast, Season 2, Episode 1. As we try to work out the identity of what exactly this podcast is, I know it's been quite a while since an episode of this podcast has come out. I'm going to be changing some things up. There's going to be significant change this season than what we had previous seasons. So without further ado, I'm not going to waste any time. Let's start talking about those changes just so that we are all on the same page and we can continue on with this at a nice, easy pace. And so probably the biggest change off the bat right here is the format. So, hey, you can see me now. We're going to continue having the audio version. It is a podcast at the roots, so we are going to still have the audio only version of this on all of the streaming services that you usually listen to this on. Apple Podcasts, Spotify, I don't know, Amazon, basically anywhere that you get your podcast and you've been listening to this podcast, you can still get it there. Do not worry. But if you want to enjoy a little bit of video and some time looking at this lovely face right here, on YouTube, under the channel Zombefied, which is my host channel, you can watch the video version of this podcast at the same time. So it'll be what do they call that? A vodcast or whatever. Either way, video going along with the actual audio as well. And so with that, I'm also going to be doing these live. So you're seeing this right now as I'm recording, then you've found the right place, and so far you've gotten used to all the new video aspect. But yes, we are going to be doing these episodes live, and then the live versions will be hidden, and I will edit, like usual, normal episode with all the audio, all that fun stuff. That'll come out a little bit later, but figured doing it live will be fun, let you guys interact and actually ask questions, all that kind of stuff. Kind of like how we did the version during Extra Life. I really enjoyed how that went, and so similar style, where I'm going to be able to read the chat and directly interact with you. Again, I know if you're listening to this later and you don't get that aspect, but again, it will be on my YouTube channel, so that's where you can be part of the next live stream. And also with the audio version of this, like usual, gonna post the photos and everything that you need to go along and follow along with the episode on the Twitter @SkywalkPod. I know I always preach it, don't worry, it's not going anywhere. Alright, secondly, as much as I love our dear, humble comet ferret Charles Messier, he will no longer be the main character of this podcast. Don't worry, I know, I'm heartbroken too. Tear running down my face. But he's not leaving completely, he's just not going to be the main star. And so, format for this podcast will be more weekly updates in the field of astronomy, science in general. I plan to pick a few big topics, typically around 3 big topics from the current week, and then I'm going to inform you about them, talk about them, I'll research them a bit, and give you all the information and keep you up to date with what's happening in the world of astronomy and just science in general, because things are changing so rapidly, especially right now. It is a great time to be interested in science. And so after the space move, we'll move on to our object of the week. This is going to be more like what you have come to know and love with the podcast from the first season and episodes that we did. except we're doing bite-sized versions. And so instead of making a whole 45-minute long episode talking about one object, we're going to make it bite-sized. So I'll pick an object, also can be submitted by you guys if you have something you want me to talk about, because we're not going to be going in order of all the Messier objects anymore. It can be any type of object. And then do the usual information, history, facts, blah, blah, blah. Again, bite-sized version, but same format for object of the week as what you've previously heard from whole episodes. And so after that, I will take some of your questions or questions that I find online and answer them. So a little bit of a Q&A. This is where the chat can also really come in handy if you want to be part of the live experience and actually have your questions answered live. Well, that would be the time to do it. If not, I will find questions to answer them and any that are posted. And then finally, we will end off with a picture of the week. And so this could be my own, it could be fans, it could be some other image, I don't know, that is relevant, but it'll be a picture of the week. And so this is a fun segment where you guys could actually submit your own images that you've taken at home or wherever and show some pride. I will pick my favorite one and post it for the week. And so just a recap of all that, the new format for each of these episodes: space news first and foremost, object of the week, Q&A, and then picture of the week. So that's going to be our format for these episodes, at least for now. Again, trying to figure out the identity of this podcast, but I think that this is a pretty good format. And so in order to better facilitate this whole new format, and especially those submissions of questions and photos and all that kind of stuff, there is a whole new side of this community. We have had the posts and the YouTube channel, but we have absolutely broadened. There is a subreddit dedicated for this podcast. And so that is going to be r/Skywalk Pod, trying to keep the same universal handle for everything. So Skywalk Pod is going to be the official community page for this podcast. It'll be an area where you can ask questions, post images, talk with each other, talk about things about the podcast or the science in general. You can submit suggestions and all that kind of stuff, and it'll be a spot where I can see your comments and interact with you, and you can directly interact with me as well. But going along with this, there's also an official Discord channel. And so similar style to the Reddit, it's going to pretty much house the same things, but with, I don't know, if the Reddit has its own flair and Discord has its own flair. So whichever you like, or if you like both, join both of those. If you need, the links to all of those will be in the description right now and when the audio and video is posted. So absolutely go check those out and we can start building this community up a little bit bigger. All right, so there's all the format. Thirdly, there will also be short form versions of these the space updates, but in the form of TikTok videos and YouTube shorts. So the YouTube shorts, same spot that you are currently watching the video, my Zombefied YouTube channel, Zombefied. That is where the video versions of this podcast are posted, and also that is where the shorts will be posted. However, there is also now an official TikTok channel as well. So again, Skywalk Pod, you guessed it, it's exactly how you imagined it. But these will be where I will post 30-second bite-sized versions of these space updates, the weekly space updates. So I won't go into as much depth as I will in these episodes, but it will be kind of the overall feel for what the news is going to be that week. Maybe I'll do it before, maybe I'll do it after, maybe same time. Haven't figured out all the little logistics of that part of it. But TikTok videos and YouTube shorts will be coinciding with this podcast as well. All right. Finally, I know there's tons of updates. I know we've already gone 5-10 minutes of updates, but there's more updates. I know this will be a bit of a lengthier episode because of all this introductory stuff, but even more exciting, we have merchandise for this podcast. So the official merchandise page for both this podcast and also the YouTube and when I do my Extra Life charity streams is called The Graveyard. It's on Teespring. And so again, link for that is down below. But it is going to be the logo, the Skywalk podcast logo with the person walking on the planet. That circle is going to be on this first run of merchandise. So just the main logo. It is just going to be on the breast side of the shirt. There are t-shirts, long sleeve, hoodies, and stickers. So absolutely go and check those out if you'd like to directly help support this podcast. The more support that we have behind it, the more I can do bigger and better things with this podcast. Because trust me, I do have a lot of big plans, but I am, alas, just a college student. So I am working with what we got right now. But hopefully, as this podcast progresses, the community grows, I'll have opportunity to be able to grow what this podcast is and what it can offer. But to show my appreciation to you guys and to celebrate this season 2 revamping and refresher of the Skywalk podcast, you can get 10% off any of the merchandise for the Skywalk podcast using code SEASON2. So SEASONTWO. Season 2, all one word. You can use that code to get 10% off all that merchandise. So, little appreciation for you guys. That code will be valid for about 2 weeks. So, again, celebration for the season 2 of Skywalk podcast. Because if you can't tell, I'm very excited. There's been a lot of work on the back end to really build up what this podcast is. So I appreciate you guys bearing with me, as it's been a little while since we've done these episodes, which is also why I paying a little bit closer attention to my notes here, because it's a little while. Need to get used to it a little bit, shake off the rust, and make sure I don't forget anything as well, because obviously there's been a lot of updates. All right, but I think that should be everything I have right now. Just a reminder, all the links for everything down in the description, so that's easy way to recap everything that I just talked about. But I will reserve the first introductory part of these episodes of the podcast, hopefully not 10 minutes long, for any updates. Like, take a couple minutes, talk to you guys directly, any updates on things relating to the podcast or just life, whatever. I'll keep that to the beginning part before we get into all the space facts and rest of the format of the episode. But again, I do want to stress one more time that please, we are working out the kinks to how this episode is going to work. So if you have feedback, if you have suggestions, criticisms, constructive criticisms, I might add, please let me know. Comments, posts, messages on the Discord and Reddit. Those Discord and Reddit will be the best and fastest way that I can see your suggestions, so I can help make this podcast better and cater it to what you guys want to see and hear. All right. But since it is a whole new season, and it's been quite a while since an official normal version of this podcast has been released, because I know we did one during Extra Life, I am going to introduce myself all the same, just so that if we have new listeners, everyone can know who I am, this man that's been talking to you for 15 minutes. What is all this about? So, let me introduce myself. Hi, I'm Gavin Moriarty, your host for this podcast. I'm an astrophysics major. I'm in my junior year of my undergraduate degree here in Arizona, who hopes to pursue a PhD in this field. Particularly, my interests lie in instrumentation. That is where I want to do my progression of education. In my spare time, though, I do astrophotography as well, along with, well, podcasts and other things. But my interest in astronomy doesn't just stop there. It is basically everything that is my personality at this point. I'm also an educator at Lowell Observatory here in Arizona, and I am working on a couple projects at my university, building telescopes and systems and all that kind of stuff. I've also done work with the IDA, or the International Dark Sky Association, doing some outreach things for astronomy clubs, and I'm a part of the advocacy program. That is apparently a very difficult word to say. But that's a little bit about me and my stretches and reaches in the field of astronomy and my interests. But it is now time, finally. I appreciate you guys bearing with me. I know that was a lot of updates. But I appreciate you sticking with me. But it is now time for us to embark on our journey through the stars. Sit back, relax, go get yourself a hot drink or a cold drink, depending on when you're listening to this, and a soft cookie. And as always, guys, star cookies get bonus points. But enough chit-chat, let's get down to the nitty-gritty. So, our first story today in space news is an X-class solar flare. So, on Thursday, January 5th, at around 7:45 Eastern Standard Time, there was a massive solar flare that was seen coming off of the sun. A big burst of plasma that hovered above the sunspot AR3182. Say that 10 times fast. But it was up there for about an hour, just kind of hovering above the sunspot. Luckily for us, the sunspot was not facing Earth at this time. It was actually kind of on the side of the sun from our perspective. But that being said, the way the sun's rotating, that sunspot is going to be facing us, and actually at this time it might currently be facing us, and could still be active. So we do have to pay attention to that, because who knows, it has obviously been active, and so there is still a chance for more activity to happen. But we've said a few words here: sunspots, solar flares, and I don't expect everyone to actually know what those words mean. And so let's go through some definitions. A solar flare is an intense eruption of electromagnetic radiation in the sun's atmosphere traveling at around the speed of light. That's what a solar flare is. You may have also heard the term CME, or coronal mass ejection. Similar but different. It's a large expulsion of plasma and magnetic field from the sun's atmosphere. So a little bit more there. Coronal mass ejection is you have actual mass coming out versus just the radiation. And then relating to these are things called prominences. These are large plasma and magnetic field structures extending out of the sun's surface into the corona. So not going into depth of all the different layers of the sun, but we're just going to summarize its surface, and then the atmosphere is, you can also call, we're just going to also call the corona. I know there's so many more aspects to the sun, but just to keep things nice and simple so that everyone can understand, the corona is kind of that glowy halo part around the sun. And so that is the corona. So prominences are these big loops that come out and then get sucked back into the sun. And then coronal mass ejections, that stuff gets launched into space. Solar flare is intense eruption of just the radiation into the air at about the speed of light. But flares can be categorized. And so they have these different classes, they're called, A, B, C, M, X. Apparently, we don't know how the alphabet order goes, but that's fine. I'm sure there's a reason behind it. And so A is the smallest, X being the largest or most intense. And then these also range in numbers, so 1 through 10, but in the case of class X, they can go higher than 10. So keep going. And so the one that we just witnessed was an X 1.2 class. So it is a rather mild version of a really intense flare, if that kind of makes sense. So still intense, but by no means the absolute craziest that we could have witnessed. Excuse me. And so we do actually think it was related to a coronal mass ejection that was witnessed on Tuesday, so a few days prior to the actual solar flare. But due to the nature of the intensity of X-class solar flares, there can be minor to catastrophic impact to radio instruments on Earth. And actually, from the one that we saw, even though it wasn't facing us, there was some shortwave radio blackouts across the South Pacific. And so we are going to see more and more of these sort of events happening, hopefully not impacting Earth too much, but expect more of these in the coming years, because 2023 right now, but the solar maximum is 2025. What that means is the sun has this cycle where it goes in the cycle of being super active to not active. Active being sunspots, solar flares, all this kind of fun activity coming off of it. And then not active where it's a ball. It's not really doing much, it's just sitting there. And so the maximum, the most activity, it peaks, we think, in around 2025. And so we're just going to see more of this. But also, if anyone is planning to go see your nice Norwegian cruise Northern Lights, now you know the year to go see it when it's the most active. But for reference of what this sort of thing can do, if that solar flare was, say, to be facing us, I'm not sure exactly about this one, but we did have very strong events related to, I believe it was a solar flare back in the 1800s, I think it was, that came off the sun. I think it was like 1812 or something. It was a really big event, and the amount of actual like electromagnetic radiation and all that was hitting Earth was so strong. There was so much electricity in the air that they could send telegrams without wire. So that's how messy it got, with just telegrams being the most intense electricity form of communication. But now, I mean, just look at how this podcast is being filmed and streamed and all that stuff. If we had an event like that hit Earth direct on, it would wipe out grids for like months. It would do so much damage. So we're hoping that something like that doesn't happen. And I don't know what the actual limit is where it starts doing damage, but I'm pretty sure X class is going to be pretty close to doing some good damage. And so that was our first story. Now let's get into our second story of the day. And so Perseverance, our lovely rover, most recent rover on Mars. And so last Friday, as of recording this, January 6th, marked the 1 Martian year on the red planet for Perseverance. So not Earth year, but 1 Martian year. And so for reference, 1 Martian year is marked by complete orbit around the sun. There's a reference point, and then once it gets back to that, that's 1 year. That's how Earth gets its year cycle. But 1 Martian year is equal to 687 Earth days. So it is a lot longer. It is also 668.6 Sol, which SOL, sols, those are a day, the Mars equivalent of a day. So it's a little bit longer than Earth, but still pretty close. And so, but almost 900 days is how long a Martian orbit is, and so that is how long Perseverance has been on the planet. And so that also means that Perseverance has been on the planet for almost 2 Earth years, because how numbers work. And so pretty exciting. It's just awesome. And that's from when it landed in Jezero Crater on February 18th of 2021. So that's when the rover actually got there. So it launched a little bit before that, got there February 18th of 21. And so Perseverance, most recent rover that NASA has sent up, launched in 2020 alongside its little buddy Ingenuity, the first helicopter on another planet, and both of them still absolutely kicking it over there. They're doing great, absolute great work. And speaking of, Perseverance roles were kind of twofold. It was trying to search for possible current or historic microbial life in the river delta that is called Jezero Crater, where it landed. But it is also making samples, rock core samples. And so Perseverance actually has just done 10 rock core samples in Jezero Crater in a spot called Three Forks. But I don't exactly know where Three Forks is, but somewhere in Jezero Crater. It's just it didn't just do its 10th, it just did its 4th of 10 that it's going to do in that spot. My bad. So it's 40% done. But it did the first capsule December 21st of 2022. So, in just a couple weeks, it's done a good few capsules. And so basically what it is Perseverance has this drill on an arm that it has. And so when it goes, it can go over some spot that they want to take a sample of, go into the ground, drill down to make like a little thin tube of rock, and then it will suck it up and put it into these sealed canisters, tubes, and then it super clean, super like tight, airtight, all that kind of stuff, clean, sanitary, and then seals it in there and then drops it and just leaves it on the surface. And so this is part of kind of a 3-step system that NASA and the European Space Agency are working together to do. And so Perseverance plan is that it has enough caps, it has 43 sample tubes that it took to Mars. 38 of them they're actually going to take rock core samples with, and then 5 they're leaving as control base test reference tubes to test the cleanliness of the tubes once they bring all them back. But NASA and the ESA are going to send more missions to Mars. The next one going to be the core collection system. It's a name similar, somewhere along those lines. And it's going to collect all those tubes, and then the third part of the mission is it's going to send all of those tubes back. And so hopefully by the mid-2030s, so in about 10 years, we should hopefully have actual samples of Martian soil on Earth that we can test and study and just learn about. And that would be absolutely cool to have actual material from not just our moon, but from another planet itself. And so, yeah, hopefully we can better understand the life cycle of a planet as well as try to find life on Mars as well. All right. So far, so good. Hopefully everyone's doing okay at home. But let's move on to our third final story of the week. And so we have discovered a new exoplanet, like officially. Exoplanet, okay, here we go. TOI-778b. I'm probably just going to nickname this Toy for the TOI, just to make it easier when I'm talking about it. But this exoplanet is called, it's considered a hot Jupiter. That is the type of exoplanet it is, which means it's roughly similar in size to Jupiter, maybe a bit bigger, maybe a bit smaller, but very, very close to its host star, meaning that it orbits around it really, really fast. It's really close to it, and because of how close it is very hot in temperature. And so these are actually kind of the most common exoplanets that we discover are these hot Jupiters. And so let's get into the stats of this planet a little bit. Exoplanet. I'll probably use planet and exoplanet interchangeably here. The distance to Toy is 5.6 million miles, or 9 million kilometers. I believe that distance is in reference to its host star. It is. It actually is. Sorry. I swear I know what I'm talking about. But 5.6 million miles from its host star. For reference, Mercury, our closest planet to our sun, is 29 million miles. So this one is only 5.6 million. For kilometers, it is 9 million kilometers away. And I don't have Mercury's conversion to kilometers. The radius of this actual planet is 1.4 times Jupiter, so 40% larger than Jupiter. The mass of it, though, even though it's just a little bit wider, it is 2.8 times the mass of Jupiter, so it is very, very massive. And its orbit, because of how close it is to its planet or its star, is 4.6 Earth days. So yes, when I said they're very close to their host star and going around very fast, I mean it. It is under 5 days. So in less than a typical work week for a human on Earth, this planet has celebrated another New Year's. So yes, you would. I think on this planet you would not have time to sober up if you celebrated New Year's every year. But because of how close it is, its surface temperature is 2,240 degrees Fahrenheit, which is 1,500 degrees Kelvin, or 1,227 degrees Celsius. Hot, very hot. It's almost as hot as Arizona, but it's pretty hot. And for something to give you reference of how hot that is, the sun, our sun's surface temperature, is 5,778 Kelvin. So this planet is at 1,500. So it's about the fifth, I guess. That's not exact measurements, but roughly like a fifth of the temperature of the sun's surface is how hot this planet is, our sun. But that temperature is hot enough that we actually think that this planet is hot enough to be able to just vaporize iron. So, yeah, iron, very, very solid metal, becoming a gas, vaporizing, it's fine. Casual. But the star that it is actually orbiting around, this planet, is 71 times larger than our sun. Big star. But it is also 40% more massive than our sun, and it spins pretty quickly. It's at 90,000 miles per hour, or 40 kilometers a second, which I don't know what the reference is for our sun, how fast it rotates. But that star, its age is just close to 2 billion years old, 1.95 billion years old, and its surface temperature is 11,600 Fahrenheit, or 6,700 Kelvin. So it is freakishly hot because it's also it's relatively new. Under 2 billion years old is pretty new in the terms of space. So it is a pretty massive hot star that it's going around. And so that's kind of the overview of the planet itself, the exoplanet. But it was discovered by a scientist at the University of Southern Queensland named Jake T. Clark. He was using the TESS, or or transiting exoplanet survey satellite. And so TESS is kind of one of our biggest it might be the biggest space telescope for trying to discover exoplanets currently. Whole sole purpose of it was to try to find exoplanets. So it's up there. It's revealed about 6,000 candidates so far. So exoplanet candidate means that it was discovered by one telescope, in this case TESS, and then in order to be a full-fledged exoplanet, it has to be confirmed by two other telescopes. One or two other telescopes. But either way, just one telescope saying that they found it doesn't make it an exoplanet. It has to have backup. But TESS currently has thousands of candidates, meaning it just needs other telescopes to confirm it. So it's doing cool, and well, we have now confirmed this exoplanet with it. And so it was discovered by transit, which means that we were looking at the star, and then we saw the planet go by in front of it, and we saw the dip in the brightness of the star. So we discovered it, and by the dip and how long it was, blah, 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 you can calculate the size and closeness to the star that this planet is. So pretty cool stuff. Transiting is a great way for us to discover exoplanets, but not the most common, because that means that the planet has to be between us and its star. So the odds of that are slim, but it does happen. And actually, the planet is orbiting around its star pretty in line with its stellar equator. So we actually think that it wasn't like a capture, that this planet didn't come in and the star caught it in its gravity, but it was actually grown there, slowly migrating through the stellar disk. But that is an exciting new exoplanet that we have just recently discovered. But that is all the space news that I have for you guys today. I appreciate you guys sticking with me. And so let's move on to our object of the week. And so for this one, sticking with a Messier object, but not going down our line and just talking about open clusters forever and globs, but we're going to Messier 42. And so this is also known as the Orion Nebula. The Orion Nebula is one of the most beautiful objects that is very easily seen in the night sky. So let's get into the discovery bit. Excuse me. It was discovered by the French astronomer. I forgot how bad I am at pronouncing names and words. Nicolas Claude Fabry de Peresque. That is so poorly and incredibly bad pronunciation, and I apologize for native French speakers. I'm sure that was painful. But he discovered it November 26th, 1610. And it was first published by Jesuit mathematician and astronomer Johann Baptiste Gisette of Lucerne. And so that was in a 1916 monograph on comets. Like he was comparing this object to comets, and he actually included in this monogram the stars that are in the center of the Orion Nebula, the very, very recognizable stars at the center. So he did include that. And there is kind of like back and forth on who actually discovered this object, because some people say that, well, it was seen before, but they didn't talk about the nebula. They only saw the stars and blah, blah, blah. But these are the discoverers that we're going to go with. But here we go, the man, the myth, the legend, Charles Messier. He ended up discovering it March 4th in 1769, so well over 100 years later. And he did also include noting 3 stars in the center of the nebula. So those stars are part of a cluster that's forming in the center of the Orion Nebula called trapezium. Basically, astronomers are very easy at naming. Basically, they said it looks like it's in the shape of a trapezoid, so it's called trapezium. Which, I mean, honestly, it's fair. It's a fair and accurate naming. And so, the origin of this object, don't really know how to talk about an origin. The Big Bang, the origin of the universe, it is a pretty dense region of hydrogen, which is most basic elements, and it was formed at the beginning of the universe, and so it wasn't really made anywhere except for when the universe was created. So, Big Bang, there you go. But here we go. If you are interested in the coordinates for where this is in the sky, our right ascension is going to be 5 hours, 35 minutes, 17.3 seconds. The declination is going to come out to negative 5 degrees, 23 arc minutes, and 28 arc seconds. So there's our coordinates in the sky. But, honestly, it's kind of hard to miss. It is a big object. It takes up an entire degree in the sky. So that is roughly like 4 times the area of the full moon. 4 times? 2 times? Either way, it's bigger than the full moon in the sky. 1 degree in the sky, which it's gonna look small, but for space objects, it's pretty big. If you take your hand, outstretch it all the way, and then hold up your pinky, that area that your pinky takes up, the left to the right, the tip of your pinky, that is 1 degree in the sky. So that is how you can tell 1 degree in the sky. Holding your hand at arm's length, holding out your pinky. And so that's how much sky the Orion Nebula takes up, which is a significant amount. The way to find this object is actually very, very easy. Orion's belt is arguably one of, if not the most recognizable things in the sky. Part of the Orion constellation, these 3 stars that make up a very straight line in the center, going across his waist, Orion's belt. And so, for the sake of this, I'm going to assume that you know Orion's belt and at least what it looks like and how to find it. If not, Google, please. But if you have Orion's belt, right below Orion's belt, and relative to how the constellation is standing, below Orion's belt is his sword. So there's 3 stars that make up his belt, 3 stars that come down that make up his sword. That middle star of his sword is the Orion Nebula. That is how bright it is in the sky that we see it as a big bright star in the sky. And so, yeah, Orion's belt, Orion's sword, middle star in the sword. Very, very easy to spot in the sky because, again, you can just see it. And on very, very clear nights, in dark sky locations, I believe you can actually see kind of a bit of a cloud around that star. It won't look like a crisp point of light. It'll actually kind of look like a fuzzy patch in the sky. And so, what do you need at home if you want to go out right now and go see this object? Well, if you have a telescope, then you can point it towards there. Any size of telescope is really going to work for this. And you are going to see this bluish gray crescent shape. So you see a collection of bright stars. Those are trapezium in the center, and then surrounding it, it's a little circle and crescent shape called that's all part of the nebula. So you'll see this grayish blue, big curved crescent, fuzzy cloud in the eyepiece. So that is what it looks like through a telescope. With a camera, though, you can do a long exposure on this, you will start to see the red. And so the part that you're seeing through a telescope is actually kind of more of the dust and everything that isn't hydrogen in the nebula. With a camera, it is magnificent, beautiful, beautiful reds and pinks. It is a gorgeous, gorgeous image to look at, and it is huge like we've been talking about. And it has a really, really bright core. If you expose it with the camera, really bright core, but beautiful and detailed filaments coming off of it. But yeah, with a camera, chances are, unless you know some really good tricks for how to expose and stack images, chances are you're not going to see trapezium because it's just going to be a big ball of light, which is what it looks like when you look up in the sky. Meaning, like, you don't really need anything to look at it. The apparent magnitude is a +4. Remember, the human eye can see to around like +6-ish, but it is just a bright object. And so to the human eye, you see this kind of fuzzy star, possibly like a gray smudge around it on clear nights. And then even through binoculars, you could probably see the Orion Nebula. It really, really doesn't take much. Your beginner scope that you bought for $100 on Amazon or $50 on OfferUp, those will be good enough to see the Orion Nebula. It is a great beginner object to see in the, but since it's in the Orion constellation, it's a winter object. So that's why we have it right now. It's going to be with us for a good few months, but it is definitely a winter object. And so there actually is some cultural history to this as well. The earliest records that we believe could be related to this nebula is actually from the Mayan culture. And so it was related, we think it could be related to a Mayan creation story. Which, please bear with me. I mean no disrespect to any civilization or history. I am going to explain this the best way that I understood from the research that I could find. So it could not be completely accurate or the same story that you have heard, but this is the story that I read and the information that I understand. And so, cosmic fire of creation is one such description, believed to be described in the 3 heart stones. I believe what it is, hearth stones. I don't know if that I just misspelt it. But it's a creation mythology. And so the 3 stones, I believe, correspond to three stars in Orion. So it is the 2 bright feet, which is Rigel and Siph. I don't know how to pronounce that. And then also the bright star Alnitak, which is in the Orion's belt. It is the one, I guess, the one closest to where a sword is. It's the one closest to where Betelgeuse is, the red star that makes up his right shoulder. So from Orion's perspective, it's his right hip. That's Alnitak. And then his left foot is Rigel, the right one is Siph. Rigel literally translating to foot. And so these 3 stars are these heartstones, and then directly in the middle, perfectly in the center of this triangle, is where this nebula is. And so, seen as a smudge of smoke from a copal incense, copal tree resin is what that is. Again, trying to understand. In modern mythology, and then in ancient mythology, literal or figurative embers of fiery creation. So that's really kind of cool and deep history. I wish I was able to find a little bit more and better ways to describe it, but it was pretty cool stories, quite honestly, that they're seeing this as like a big fire of creation, which now with modern technology and understanding of it's a stellar nursery, the Orion Nebula is a stellar nursery, so all that hydrogen gas is making new stars. That's what the trapezium cluster in the center is. And so they're calling it this fiery creation for their own creation. I believe, I'm assuming, they're talking about just all creation. And sure enough, it is actively making new stars. So absolutely cool, that correlation there. And so, yeah, like I was saying, stellar nursery just meaning that it makes new stars, it raises baby stars, stellar nursery. And so trapezium, that cluster that is very notable in the center, about 4 or 5 bright stars in the center, very young, very hot blue burning stars. Those are new stars that were actually formed in the nebula and kind of what are illuminating the entire thing. They're very new stars, very powerful ultraviolet light is what they're giving off. And the stellar winds are kind of what's sculpting the nebula itself. So why you get those strong filaments and shape of it is because a lot of radiation, ultraviolet light, but mostly those stellar winds are pushing all of that gas around, which is how it's going to start forming new stars in other areas, because this star has now pushed gas that way, and so that starts to clump, and then everything is gravity-based and space, very easy to snowball. And so you just keep collecting more, new star is formed, and then strong stellar winds pushes stuff other way, and so on and so forth. And so a cool endless cycle until all the gas is used up, which, for reference of how far across the Orion Nebula is, it is about 24 light years across, or multiply that by 6 trillion, and you have it in, you have that in miles. So good luck with that mental math, because that just hurts. And so the Hubble in 2006 photographed the sharpest image ever of the nebula. It is a gorgeous image, and showed thousands of stars for the first time that we had never seen before. The European Southern Observatory, the ESO, a very large telescope, they took photos more recently than that with their big Hawk 1 camera, and they found planet mass objects and brown dwarfs. So basically things that weren't as big as stars, so more planet sized and massed, and brown dwarfs, which are kind of these weird semi-stars. So really, really cool that we're seeing all these different stages of creation, all just within this one nebula. And so if you're looking at images, particularly, I believe it's the Hubble image, hydrogen in that Hubble image is going to be orange. It might be, I forget if it's the Hubble or the ESO image. Hydrogen is orange, oxygen is green, sulfur and infrared is red. But for human eyes, if you're taking photos of this at home, all the red is going to be hydrogen. That's what you see in visible light. They just change the color sometimes just to help visualize different elements. But yeah, that's the Orion Nebula. Absolutely amazing object. I love taking photos of this. I love seeing it. It never gets old. You get the chance to see it in some bigger telescopes, like at Lowell Observatory we have a 32-inch and a star structure and a 24-inch Clark telescope. You can actually, with the human eye, start to see some of those red colors come through. It's so cool. It is absolutely a gorgeous, gorgeous object, and yeah, I can't say enough good things about the Orion Nebula. It's just amazing. All right, but that is all that I have for the Orion Nebula. Let's move on to our Q&A. And so, I know that this is a bit of a longer episode. Like I said, it's probably going to be a longer episode. I will probably end up shortening this down. My original goal is actually to go for 30 minutes, and so we're a little bit longer than that, which is fine. It's good. A lot of good information, a lot of cool segments, a lot of cool objects, but I know that we're hitting close to that 50-minute to an hour mark, and so we're going to try to get through these last couple segments a little bit quicker so we can start wrapping things up. And then for next time, we will make those other segments a little bit shorter, and I don't think I'll have as much updates in the next episode. And so here's some questions that I found online that I will try to answer, because some of you may have similar questions to this. Again, please submit your own questions. I'd love to hear from you and answer your questions that you have. They don't have to be directly related to anything I'm about to say, but any questions you have about astronomy, I will gladly answer. May not be serious, but I'll answer them. So question 1, how is the Milky Way in the constellation Sagittarius? I have actually heard this one before, even just working at Lowell. And so if you were to look up the Milky Way and go onto like the Wikipedia page, it says it's in the constellation Sagittarius, which is confusing because, galaxy, constellation, how does that make sense? So let's define a couple things. Constellation is a section of sky with bright stars kind of connect the dots in them. These are my definitions. The Milky Way is a galaxy, or basically, in summary, hundreds of billions of stars, planets, nebulas, blah, 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 etc., all orbiting around a central supermassive black hole. Again, I'm summarizing things. This isn't always a blanket statement, but I'm making it a blanket statement for this. So, galaxy, huge, hundreds of billions of stars to trillions of stars. And then constellation is, from our perspective on Earth, a section of sky that we've connected the dots with some bright stars within it. But constellations are actually a whole section of sky. And so constellations that we know only exist to us being Earth. It's a way for us to have directions, reference points when looking at the sky. The Alpha Centauri system, the closest stars to us, their sky is going to look different than ours. Some things may be similar, but the stars will be in different positions for them than they are for us. And so they will have different constellations if there are humans there. So all of these stars in the sky also are likely at most like a couple thousand light years away, but as close as 4.3 light years away with the Centauri system. And so just a couple light years away, all within the Milky Way. We are in the Milky Way galaxy. All those stars, like I said, a couple thousand light years. The Milky Way itself is about 100,000 light years across. So it is very large. And the stars we're seeing are only a couple thousand light years away from us. And so when we're looking up into the sky and we see the Milky Way go up, also called the band of the Milky Way, what we are seeing is the inside. So the Milky Way, think of it as a plate, like a dinner plate. We are close to the edge of the dinner plate. We're relatively on the outside of the dinner plate. And so that is the galaxy. And so when we see this line of the Milky Way going up in the sky, that is being on the outside of the dinner plate and looking inwards. And so you're seeing all the rest of that galaxy relatively all in a straight line, because the galaxy is pretty flat, all things considered. And so that is the actual line you see in the sky. That is just looking inwards. And so that is mostly in the summertime, for Northern Hemisphere at least. In the summertime is when you get the middle of the Milky Way. And then in the wintertime, like now, we really can't see much. You don't get really much of anything of the Milky Way going overhead, because now we are looking outwards. We're on the outside of the dinner plate looking outward. So there's really nothing in between us and just vast space. So hopefully that makes sense so far. And so there's this line going up in the sky. Well, it cuts through the sky somewhere. We need a reference for it. And so in the summertime, we have the constellation Sagittarius up in the sky, and the band of the Milky Way cuts through the constellation Sagittarius. But particularly, the center of the galaxy is located in the direction of Sagittarius. So it's not in the constellation, it is from our perspective in that direction. And so That's also why we named the black hole at the center Sagittarius A star, because it's in Sagittarius. That's where the black hole, that's roughly the direction it is in. So the Milky Way itself is not in a constellation. Constellations are stars for reference, but our reference point, the Milky Way, looks to be in that direction towards Sagittarius. That's the meaning of the Milky Way is in Sagittarius. It is that reference point. And so another question that we have is the phrase observable universe. What is that? How can there be a non-observable universe? For sake of time, we're going to go really high level with this. Observable universe, all the things that from Earth we can see, or we could potentially see. So that is roughly 100 billion light years away from us, more or less in a circle, in any direction, 100 billion light years away. The entire universe is unknown. It is infinite. It is everything that is everything. We're not going to get philosophical and try to lose our sleep over this, but it is everything. It is the observable and whatever is beyond the observable universe, which we just don't know because we can't observe it. And so it all comes down to two factors, why we have this distinction. Because, again, we think that there's more outside of the observable universe, but we just can't see it. And so there's two things here. The speed of light, which is 3 times 10 to the 8 meters per second, or 300,000 kilometers every second. And then the rate of expansion of the universe. The universe is expanding due to dark energy. We don't understand it fully, but it's expanding. Everything is expanding outwards. And that is at 73 kilometers per second per megaparsec. Parsecs are not just in Star Trek, they are an actual unit of measurement. It's what scientists actually use for calculations. But I'm not going to go into that whole rabbit hole. But basically, rate of expansion is fast and getting faster because of dark energy. And so, because everything is expanding away from each other, so we are, think of it less that everything is moving away from us, but everything is moving away from everything else in reference to everything. So yeah, you can think of it less. I don't know. I think an example I saw was like if you had a stretchy ruler and an ant, and 2 ants, one at 0, one at 1, and then you pulled the ruler away from each other. Kind of imagine that expansion, but everywhere. So from one ant, it looks like the other one's expanding away, but the other one sees that the other one is expanding away. But anyways, so everything is moving outwards, away from each other. But it's moving at a rate per distance, that is the megaparsec. So every megaparsec, you have more expansion. And so the farther away you get, the faster away things are actually moving from us. Which means as time goes on, especially since this number is increasing of how fast everything is moving, everything that is outside of 19 billion parsecs away from us, that light will never reach Earth. Things are expanding. It's far enough away that it is expanding faster than the speed of light can come back to us. So we will never, ever see it. And again, as this expansion increases, that number is just going to get closer and closer to us. Eventually, we're not going to be able to see anything outside of just the little cluster of galaxies that we're part of. Not in our lifetime, don't worry about this. Please do not stress over this kind of stuff. But anyways, that is why we have the observable universe, because there is a limit to what light can actually come back to us, what we can actually see. But there are things out there. They're just gone. They're just farther than what we can see, which sucks, because speed of light is the speed limit of the universe, and we can't send mass, i.e. humans, at the speed of light. It takes infinite energy, so we can't do it. You'll just never see that stuff. And so, basically, as the universe expands, we see less things. All right. And so, last question. The New Horizons spacecraft, how did it navigate the Kuiper Belt and not get destroyed? And so, the Kuiper Belt is a bigger asteroid belt outside of our solar system. Much, much bigger. But basically, the answer to that is pretty simple. Space is big. Space is big. There's a lot of stuff in it, but things aren't really close together. The Kuiper Belt is not that dense. The Kuiper Belt spans 30 to 50 AU, which 1 AU is the average distance the Earth is to the Sun. And the average spacing between objects is like a few million kilometers between each of these objects. So if you look up images online, asteroid belt, Kuiper Belt, whatever, it looks like this really dense cloud, but there's a few million miles on average between, or a few million kilometers on average between each of those objects. And so, yeah, and so, the average chance of an asteroid that is 1 kilometer big in diameter, whatever diameter, 1 kilometer asteroid, the average collision of a 1 kilometer asteroid is once every few billion years, possibly only a couple times in the entire time our solar system will be here. So the New Horizons spacecraft was basically the size of a small car. It was 7 feet by 7 feet by 9 feet. So just keep stacking a few refrigerators. And so basically there's so much room between objects, you don't really have to aim, you just send it and chances are you're fine. I'm sure they did do calculations, but again, the odds that it's going to collide are so incredibly low. You'd have to be actually pretty accurate in order to hit something. All right, last segment, picture of the week, very easy. Picked a photo that I took a few weeks ago in town here. I actually took it just from the parking lot of my apartment complex. It is an image of Mount Humphreys here in Flagstaff. Mount Humphreys Peak, there was some clouds. It was very beautiful, but it was at nighttime. So some basic landscape astrophotography. It had the peaks, but it also had some bright stars above it, which are part of Draco. I forget which star exactly, but one of the bright stars in Draco, you can see above it. And so you see a nice few stars above it. I just really liked it. It is a very easy image, or very elegant image for how basic it was. It was easy to take. Just DSLR camera, my Red Cat camera lens, and like a 3-second long exposure. Really wasn't that much, and then some post-processing. But it's a really nice image. I've come to like it. All right. And so I know this was a long episode. I know I've been saying that a lot, but I think we are pretty good to go ahead and start wrapping things up. We have gone through all of our segments, and so why don't we start closing things up a bit? And so thank you to everyone, my stars in our own little sky, for sticking with me through this and through all these changes that are happening to this podcast. I think this was a good refresher. I think that this podcast needed a little bit more pep in its step, a little bit of a refresher. It's starting to get a little stale. But again, I want to know what you think. Please, please let me know on Reddit, Discord, Twitter, whatever you want to do, wherever you want to leave it, the comments of the video. Let me know what you think. Thoughts, ideas, improvements, constructive criticism, praise, whatever you want to do. But I want to hear from you and how you enjoyed this new season and new version of this podcast. And so there will be a post on the subreddit, Twitter, and the YouTube video where you can directly comment and leave thoughts. I might post something, but honestly, you guys can just make your own posts. But yeah, what you like, didn't like, and also what you want to see in the future. But as always, check out the Twitter at SkywalkPod for this episode's photo dump, and check out some of the previous episodes we've done, especially if you're new here. Go check out the previous episodes. We did have co-hosts at one point. I'm hoping that maybe in the future I will be able to have different co-hosts, just so that you guys don't have to sit and necessarily always listen to me. And back and forth banter is always nice. It keeps things fresh. But that is also where you can stay up to date. Join the TikTok to get your kind of quick fix of space news and updates, and other supplemental content that I might do. Maybe I'll do some behind the scenes stuff and all that kind of stuff as well. The setup that I currently have for recording this is quite hilarious. But if I can ask one thing of you, the audience, if you want to help out this podcast and allow us to do bigger and better things in the future, please, please, please rate, comment, and share this podcast. That is how this podcast and community can grow. Word of mouth, absolutely the best way to spread information. And so rating 5 stars, liking, and commenting are all the ways that can help this podcast get recommended, using all of the algorithms on the websites and services that the podcast is being posted to. But word of mouth, just tell one friend. All you gotta do is tell one friend, have that friend tell one friend. And then from there we can grow this community, and that would really help. But with all that said, I think we are good to wrap up. This has been the Skywalk Podcast, bringing you your weekly dose of space news and facts. You have all been wonderful listeners, and I will see you all next week with another episode. Bye.